You're watching the part 2 of the Unity series where we're creating a bunch of games. We looked in the first part where we created a very simple gem collection game. It was extremely simple. So now we're gonna up the complexity a little bit, just a tad little bit, and we shall make a Breakout clone, the classic Breakout game. And this is what it's gonna look like. So let me drag my editor window on here. Alright, and let me just play it for a little while. So you're gonna see the bricks here and the paddle, the ball, and hitting control will shoot the ball, and you can just move with you can move with your arrow key back and out to the left and right. So that's the movement code, and it's a very simple breakout game, and you don't have variations in the bricks, so you don't have any special power-ups or any of that sort. But we will be creating a different brick game where you will be having all those power-ups. Okay, so hitting control shoots the ball, and you can just move around and play the game as Breakout does, and game over. And it's actually not a very simple game to play, but we're gonna make it anyways, and we'll worry about a complex Breakout game further down the series. Okay, so create a new package with create a new project, create a new project, a 3D project with no asset packages included, and hit create. Okay, so a brand new blank project, a 3D project. So let's follow the regular drill. Let's create folders here. So materials first, and scenes, prefabs. Let's have scripts. That's capital. Scripts. Okay. What else do we need? Scripts file. Okay, I think that's all. Okay. Let me import my Visual Studio package. Where is it? DevTools, Unity, packages. Yeah. Okay. Okay. All right. What do we do now? Let's first create the walls and the roof and all that. So let's get started by creating our first cube. Okay, so we are creating the wall. Let's this cube. Okay, we're not going to be looking at the game view yet, so let's just be looking at the scene view. We'll just be looking at the scene view and looking at it from this angle and the way we want it. Okay, so wall. So let's first call this left wall. Okay, this will be the left wall. Let's first scale it up to 20. All right, that's 20. That's good. All right, I don't know. Okay, I don't know why I added 360 there. Okay, let's save the scene while we're at it. So it's called the main scene, and we're gonna move the wall to -10. Okay, and let's create a right wall. Dock it here. Right wall, same dimensions, x is 10. That's it. Alright, and now let's create the roof for the level. It's gonna be 1 and 24 long. Alright, and let's rotate it to 90 degrees and move it up, say 10. Alright, good enough. Okay, next let's just create some background. Let's just create not a background, let's just create a base. We'll call it the base, and let's make it 50 in the X, 20 in the Y, and 50 in Z. And so this sort of contains the whole level, so we're gonna move it down to, say, minus 21. No, minus 20, I believe. Yeah, that looks good. Okay. All right. That's base. All right. So now let's create materials for all these guys. Material. Let's call this matte blue. Shall make it blue. Okay. Matte red. Okay. And we gotta rename this to matte red. Okay. Let's also create a matte green while we are at it. We might need it. I don't know. Matte. Okay, that's obnoxious green, but it's okay. So we're not gonna meddle around with the metallic and the smoothness features here, so we'll just leave them as it is. And let's now create, let's actually add the materials, the red materials to both of them. All right. And okay, that's the roof, so let's call this the roof. Let's also make it, how about, no, not blue, how about green? Really, I think red is good. Yeah, let's go with red. All right. Okay, now we gonna be working on the bricks. We're gonna be creating the bricks. So let's first create an empty object. No, not now. Let's create a cube and call it brick. Okay, let's call it brick, and let's what are the dimensions gonna be? The dimensions are gonna be 2 in the x-axis, 1 and 1. Okay, and let's give it the green material. So that's our first brick. Let's position it to the left corner. Let's say 7 and minus 6. Not minus 6. 5. Oh, come on. 8. 7. Okay, minus 7 looks good. Also the ball can slide between them. Okay, now that's brick, and let's create another brick. Place it down here. Take off the one thing, and let's say minus 14. Oh no, 0. No. Okay, let me just eyeball it first and then I can figure it out. So minus 7 and minus 4, minus 3, no, minus 4, 5, 6, 0.5. Okay, this looks good. So 4.5, that looks good. Yes, copy them both, paste. Okay, take off this, take off this, and okay, so this is minus 7 and minus 4.5, minus 7 and minus 4.5, so that's plus 2.5. That's the difference. So minus 4.5 plus 2.5, that is minus 2. So this will be minus 2. So minus 2. Okay, so minus 2 plus 2.5, that would be 0.5. Okay, now I think there's room for 2 more bricks at least, so 1 more. Okay, this would be 0.5 plus 2.5 is 3. Okay, so 3 plus 2.5, that would be 5.5. That would be 5.5, and we end here. So that would be 6 bricks in all. So that's it. Okay, now we got 6 bricks in all. So first let's move this. Okay, I'm gonna eyeball them first. Yes, that looks about fine. Okay, now duplicate all of these 6 bricks, bring them down by, I think this looks good. Let's say 5. 5 is good. Okay, so we're gonna make 4 rows of them. So that's, select these. Okay, so let's actually look at the 7 and these are 5, so that's like a difference of 2. So the next one would be 3. Okay, and the last group would be 1. Oh wait, duplicate them first and then 1. Okay, I think that looks good to me. That looks good to me. Yeah. Okay, now just go around and keep changing the names. Actually, I don't have to do that. I just have to say brick. That's it. All right. Now, this, bring them all down. Okay. Are these the right objects? Good. Okay. Now let me create a new empty object and let me call this bricks, and drag and drop all of these. How many are they? There should be 24, I guess. Yeah. All right, cool. Okay, so that has, okay, now let me drag and drop, let me drag bricks to the prefabs folder, create a prefab. Okay, and I want to count them out. 24. Good. Okay, fine. All right, so now let's move the camera, let's move the camera so that we can see the level better. The base, okay, the base has to be given a color as well. Let's say blue. I think the base will get a blue color. Okay, camera is gonna be at minus, let's just make it minus 20. Good. It's good enough. And all right, okay, and make the skybox as a solid color and give it sort of this color. Oh no, wait, yeah, this is a classic Breakout with the shadows of the bricks and all in the background. Yeah, this looks good. I think this looks great. Yes, this looks great to me. Okay, now since we have these walls that are directly vertical without any angle, so when you add physics and all, so it's not gonna look right. So we shall also change the orientation of the walls just by the left wall will be, no, -3, -3, -4, I guess. Let's make it -4, and right wall would be 4, and let's shift them a little bit to the right, and let's say -12, no, -11. Yeah, -11 looks good. This will be 11, so that it looks like the ball has space to move around the sides or the corners. All right, so now it's time to make the paddle. Let's create another cube and let's zero it out and let's call it paddle. Okay, and let's position this in a way like this. That would be 9 point, let's say 9, yeah, 9.5. Now let's make it 9. I think this looks good. Yeah, this looks just fine. Okay, and we're gonna create a cube, no, sorry, a sphere, which is a child of the paddle, and we will call it the ball because the ball is going to be attached to the paddle when it launches, right? So where is the ball? I think it's inside, and it's huge. So we have to first position it up 1.5 and scale it down by, oh, hang on, first let me actually scale my paddle. My paddle does not look right to me, so my paddle is supposed to be 3. Yeah, my paddle is supposed to be 3, and now let me create a sphere. That will be the ball. Actually, let me first create the sphere and change it to half its size. Let's see where the sphere is. 0.5, 0.5, and 0.5. And now let me move it to the paddle. 0. And what does it look like? It looks too tiny. Okay, let's just increase this size by 3.1. Oh no, wait. Okay, 1.1. Okay, that's because that's what you're not supposed to do. So let's make it 1.1.1. Okay, so now that I've made it 1.1.1, this is the right size. So let me add it, and now I got the right size. That's 0.3. Oh, let me just keep it. Maybe to this precision, yeah, won't make a difference. Or let me just keep it, and that's okay. That's okay. All right, 1.5. Yeah, that's a better height. Okay. So now besides that, now that we have the paddle and the ball, gotta rename that to, come on, ball, and the paddle becomes a prefab. Now you have to make a physics material for the roof and the walls so that the ball can bounce off those surfaces. So first let's create a physics material. Let's call this mat underscore bouncy, and that is gonna have 0 dynamic friction, 0 static friction. It's gonna have full bounciness. That's the complete bounciness, and we're gonna leave everything else as is. Now select left wall, right wall, and the roof, and we're gonna assign a physics material, the bouncy, to the material section here in the box collider section. Okay, now, okay, that's all we need for now. Let's see, got the bricks, you got the paddle, you got the materials in, and I think it's time to start scripting. Well, before we start scripting, we gotta make sure that both the paddle and the ball have a rigid body attached. Okay, and turn off gravity is kinematic, and that's it. All right, we're gonna need we don't need any angular drag. That's okay. Angular drag is okay. Okay, now let's create the scripts. The first one we're gonna create is gonna be called paddle. So we will use the script to move the paddle, as it says. Let's first add it to the paddle straight away, lest we forget. Alright, let me close the calculator. Okay, alright. Let me open my Visual Studio, generate project files in Visual Studio. Alright, it's opened up here. Okay, let's open paddle.script, paddle.cs. Okay, let's delete all of the internals as usual because we'll use them when we need them. Okay, so paddle first is gonna need a float variable called paddle speed, which will be tweakable via the editor. So we're gonna give it an initial speed of 1f. If we find it too slow, we can tweak it as we like. And then it's gonna need a private vector 3, and that will be the player position. So, and that will be starting off at 0f and 9f 0f, because our paddle is always at 0 minus 9 0. So that's going to be the initial player position. So we're going to hard code that, which is okay. And now we just need the update function, and all we gotta do is we are supposed to look for the x position change by and okay, let me write the code and read it from left to right. So first we are looking for the position.x, and we are adding that to any input that your keyboard might have received in the horizontal axis, which means that either your A or your D key or your left or your right key on the keyboard, and we multiply that with the paddle speed, which is 1. So it's always going to be the same amount. So but since it's a variable, so it's always good to multiply that with paddle speed. Okay, now let's change the player position, and now let's update the player position. So we found the x position because this game obviously it's a breakout, so it's only going to be moving in the negative x to the negative y, negative x to the negative y direction. It doesn't have any vertical movement, so we just worried about your x position. So let's create a new vector, and we are going to be clamping this between some value. Let's find out what value that is. Let's go to the editor. Let's just try and move and find out where it is. So this minus 8.7, so let's say 8 or 8.5. Okay, 8.5 to 8.5. all right, so we found the range. It's minus 8.5 to 8.5. okay, all right, let's go back. So now we know where to clamp. So we're going to be clamping so that we don't move beyond those walls, the left and the right walls. So we say first we are going to be clamping x position, the position that we found out, the calculated position, and we're going to be clamping the minimum value is going to be minus 8.5f to 8.5f. okay, and when you close the bracket there, and let's give it the y coordinate, that's always going to be 9f, and no z axis. That's it. Are we missing a bracket somewhere? No, that's good. Okay, and then transform.position and equals player pose. That's it. So now we are attaching that to, we already attached it, right? We already attached it to our paddle. Yes, the paddle speed. So let's see if it even works. Oh wait, okay. Oh, it's supposed to be minus 9. Okay, that works. So it's clamping, so I'm moving along and it's clamping fine, just fine. Okay, that's good. So okay, alright, so next up let's write the ball script, and we shall cut the video and we'll continue with the next one. Okay, so let's call it the ball. Alright, reload all. Yes, open ball. We don't need this. Okay, so first things first, this ball is gonna need uh, an initial velocity, so we'll call this ball initial velocity. That will be 600f. Okay, so that's going to be the initial velocity. Next up we will see we need a reference to the rigid body, so say ball rigid body equals null. Next up we need a boolean variable to find out is ball in play, so has the ball been shot from the paddle yet or not. So that's the boolean, that's the job of this boolean. uh, let's check it out in awake function. What do? We first get the rigid body of the ball, so get component and rigid body. Okay, now we got the rigid body, and now the whole script only uh, pivots around the update function. That's the whole script about. So we will look for the fire key, the fire 1 key, or the control key on your keyboard, or the fire 1 key or the left mouse button on your mouse. So we'll look for input from any of these two parameters. If it's clicked, if the control key is clicked, then you release the ball from the paddle. Right now it's a child of the paddle, so it'll move along with the paddle everywhere you go until you release it. So let's first check it for input. So let's say input dot get button down, fire one, and if it's not already been released, go ahead and release it. So fire one is mapped to your control key and your mouse button, left mouse button, uh, in the input manager in Unity. So if you go to okay, let me show you that. If you go to okay, a file, project settings, input, go to access, fire one, so it's left control or the mouse zero. The mouse zero is the left mouse button. So it looks for a key press or a mouse button click, and if it finds it, then it's gonna release the ball. So how do we release the ball? Because it's already parented, so you first have to unparent it. So let's say transform.parent equals null. So we are gonna make the ball an orphan. We're gonna take we're gonna be taking away the ball from its parent, the paddle. Okay, and we will set boolean flag is true, so you can't release the ball again, it's already been released. And then we will access the rigid body of the ball, and then we're gonna say is kinematic equals false, so which means that at this point, as soon as you release the ball, we want the physics system, the Unity physics system, to take over. Okay, and now that we are ordering for the physics system to take over by making the iskinematic flag to false, we can add force easily. We can say not ball dot, it's ball rigid body, add force. So where do we wish to add force? So first let's create a new vector 3, and we wish to add a force of initial velocity of ball initial velocity. Okay, and again ball initial velocity in the y as well, and we don't need any z force. So the physics system is going to take over. It's going to take care of, it's going to handle all the physics things that it needs to work on. So let's see if this works. So let's save it. And does the paddle have the ball script? The ball has, okay, the ball does not have the ball script, so let's add the ball script. Paddle is fine. Okay, let's see. So we are first moving and I'm hitting control. There you go. Okay, now since it's stopping because we haven't controlled the collisions with the bricks yet, so that's okay. All right, good. So we have taken care of input and releasing the ball and sort of physics. So if we didn't have the, let's say we didn't have the bricks at all, let's actually take off the bricks and let's see what happens. So let's see. I don't know why it slows down. Maybe it's because of the angular drag. Let me check it out. Okay, so I believe we do not have the physics material yet. So both the paddle and the ball are also going to need the bouncy material. So we added the bouncy material to the left wall, the right wall on the roof. So we are also supposed to add it to the paddle and the ball, else they're going to have trouble interacting with each other, right? So let's drag and drop matte bouncy on paddle and the ball. So now let's see how it works. Great. So now we have the mechanics. We have the mechanics down for uh, shooting the ball from the paddle and the ball bouncing around the walls and the roof and all. The next step is going to be writing the logic for the bricks and writing the destruction logic for the bricks and all that. Thank you. So we're gonna go ahead and write ourselves a game manager first, which will control the whole game. And after that, we're going to be writing the brick script for checking the collision of the ball on the bricks and destroying them as we need. So that logic will come in the bricks class, but there's going to be a game manager class that manages the entire game. So let's go ahead and create a C# script for ourselves and call it game manager. And let's also create an empty game object and call this game manager. Now let's drag and drop game manager onto that object. Before we go ahead and write the code, we are supposed to also create the canvas items, the UI items, because the game manager is going to take references for the UI items, and if we don't create any, then we might forget it later on. Or let's just go in a linear fashion and create a canvas for ourselves first, and let's just create all the UI elements and that goes along with it. So we're gonna need 3 text items. The first one is gonna be a text lives, txt lives, and that is gonna be docked on to top right. So we're gonna dock it here, and obviously we're gonna change it's black text against a black background. So first let's change the text and let's make it read lives 3. So there are going to be 3 lives when you get started, when the game starts. So it's going to be a bold font, 32 size, and it disappeared because the width and the height is not sufficient for that font size. So now we'll fix that without actually playing around with the width and the height. So when you say overflow, you're gonna get it back, because overflow, horizontal overflow and vertical overflow, like we discussed in the previous chapters, overrides the width and the height properties of the rect transform. Okay, and let's also change the color to something that's easily visible, like white. Yeah, white is good. Or let's, how about green? Yeah, this looks good. Okay, and let's bring it down by, yes, this is fine. So let's round it up by 23. Yeah, 23 is good. And next up, we're gonna need a txt game over and a txt u1. So let's change this to txt game over, and this would be txt u1. Okay, both of these are going to be sitting in the center, so I select them both, click on this presets, anchor presets, hit alt and hit the center. Now let's change the text. This is going to be, okay, this is game over, right? So we'll just say game over, and it's bold 64. All right, and we won't start off with this text showing up as the game starts, so let's turn this off, and this would be txt game 1, so u1, again 64. Everything else can stay the same. That's it. That's all we need for the UI canvas thing. Okay, now let's go on for the game manager. So now that we created the game manager, let's go to Visual Studio or Mono Develop if that's what you're following along with. Reindent it. delete the internals of the file, and let's start writing some code. First up, we're gonna need how many lives the player is gonna have. So that'll be an int variable with 3 lives. And how many bricks do we have? How many bricks do we have? We have about 24 bricks, I guess. Let's count. 1. If I select them all, it's 24. So it says previewing 8 of 24, which means there are 24 bricks. That's not going to change. We'll create a more advanced version where you're going to get different variations of bricks and different power-ups. So for now, we're going to keep it extremely simple. Alright. And next up, we will have a public float variable, which will say reset delay. So this is the delay or the time that how do I say it? The waiting period before the game resets itself. So that's a delay. That's a number of seconds reset delay variable represents. And next up, we will need we need a declaration for Unity engine .ui. Okay, now we can access all the UI elements. So we need a reference to the text lives, so we'll keep it as null first. Then we are gonna need a game object, game over, so which corresponds to txt game over. So but we need a game object so that we can turn it on and off. Now you could keep this as text. I mean, you can say that public text txt game over, but if you want to deactivate and activate a text element, a UI text element, so you need to access the game object and then you have to say set active. While if you have a game object, you can directly set it as active, set active as true or false. Since we're not going to change the text for game over, it's going to stay the same, so we don't need a text item. Out here, the lives, it's a dynamic text, so we will access the text lives and change the text to the number of lives remaining at any point of time. So that's the reason we are having the game over and the game 1 or u1 as game objects, while the text lives as text type. Okay,